obtain equation governing a particular physical system, especially a system that has been studied via experiments. There are two basic physical factors we need. Physical factors which are gotten as significance of certain practices carried out on graphs which we plot or sketch. One of such physical significance is the slope or gradient. What is slope or what is gradient, and how does it contribute to developing a formula that governs a physical system? That takes us to lesson number 5, and that is the meaning and application of slope. Please listen.
Permit me to use this table to explain the concept of slope or gradient. Slope is defined as rates of change between dependent variable and independent variable. This definition may not be sufficient for us to get the exact meaning of this slope. That is why I seek that I use this table to explain it. This is our first table. Recall, this is a table summarizing rate of consumption of petrol by a given vehicle. I hope you remember. Now, concentrate on this column that describes changes in the volumes of petrol consumed by the vehicle. When the volume changed from 2 liters to 4 liters, what is the actual change that took place? It is 2 liters, an increase of 2 liters. If I say change here, an increase is what I mean by change. A change can also be a decrease, but in this one, the increase or the change is an increase. Therefore, from 2 to 4 made an increase of 2 liters. The same thing applicable to 4 moving towards 6 liters. That is from 4 liters to 6 liters. An increase of 2 liters was effected. First, how did I get the change of 2 liters? It is either you say 4 minus 2 or 6 minus 4 or 8 minus 6 or 10 minus 8. In each of these, we find out that the change that takes place when the next volume of petrol is put is equal to 2. Therefore, we write this. Say it here. Delta V is equal to 2. What does this mean? We know that V refers to volume. What then does this delta refer to? Delta is a Greek alphabet, but it was employed here to show a change. Change in this case, in this particular case that concerns us right now, is an increase. Therefore, for now, this delta represents the increase. Increase in volume. Increase in volume. Then the increase in volume is 2. I hope you know how it was gotten when I was talking about it. Then how was this 2 gotten? The 2 was gotten simply by saying V2 minus V1. V2 means a volume after the first. That is, a volume that succeeds the 1. This precedes. This succeeds. That which precedes is called V1, and then that which succeeds is called V2. If it is 4 and 6 we are trying to compare, then 4 precedes and 6 succeeds. Therefore, in that case, with respect to 2 and 4, our V2 is 4 and our V1 is 2, so that 4 minus 2 is equal to 2. If we are comparing 4 to 6, our V2 is 6 and our V1 is 4. So that the change in volume is equal to 6 minus 4. The same thing is going to happen if you keep going down. Now, what about this column? When the volume of petrol was changing during the experiment, was distance also changing? Yes. When the volume of petrol that was put in the vehicle changed from 2 to 4, the distance the vehicle could travel before finishing the petrol also changed from 4 to 8 kilometers. Therefore, a change in volume brought about a change in distance. Again, when the volume changed from 4 to 6, the distance traveled changed from 8 kilometers to 12 kilometers. When the volume changed from 6 liters to 8 liters, the distance traveled changed from 12 kilometers to 16 kilometers. Let us again see how to express change in the distance. As you can see, delta D is equal to 4. Do you agree with me? As before, this delta represents a change, in this case, an increase, while this D represents this distance. Therefore, this is change in distance. Change in distance, or in this case, increase in distance. Increase in distance. So, increase in distance is equal to 4. How was this 4 obtained? The same process. It is either we say 8 minus 4, where 4 precedes, that is D1, and 8 succeeds, that is D2, so that change in D is equal to 8 minus 4. If we compare 8 with 12, if we compare this 8 with 12, 8 precedes, that's D1, and 12 succeeds, that's D2. Therefore, change in D is equal to 12 minus 8. Again, that is equal to 4. The same thing is going to happen if you go down to this last figure. Therefore, we now summarize that whenever volume changes by 2, that is, whenever volume of petrol increases by 2, the distance the vehicle will travel will change by 4. It is comparison between these two changes that we refer to as slope or gradient. If I say comparison, comparing two things can come in several ways. In what sense are we saying comparison? Let's find out. When we define slope as rate of change between the variables, there is just one thing we had in mind, or I had in mind when I was making that definition. But this time around, we're going to use these two figures to say exactly what I mean by rate of change. Rate of change between the distance and volume is not by how much this distance is more than this volume. Instead, it is how many times this change in distance that has occurred with respect to the change in volume. In plain terms, how many tools are in 4? That is, if change in volume is 2 and change in distance is 4, how many times of change in volume has occurred to give us change in distance? Meaning, how many tools are in 4? I repeat, how many tools are in 4? Or how many delta V's are in delta D? In this case, if we want to know how many tools in 4, what do? Certainly, we don't subtract 2 from 4. We subtract 2 from 4 if we are asking, if we want to know by how much 4 is more than 2. But in this case, slope is not by how much 4 is more than 2, but how many times that 2 multiplied to give us this 4. Simply put, how many 2's in 4? Please, if we look for how many 2's in 4, what do we do? Let's see. To get how many 2's in 4, we say 4 divided by 2, and that will give us this 2. That is change in distance over change in volume is equal to 2. What it means is that anytime volume changes by any value, the distance will change 2 times. Anytime the volume changes by any amount at all, the distance will change 2 times as much. What it means is that when this volume changes 10 times, the distance will change 20. That is, when the change in the volume is 10, since change in distance will be twice 8, it means that change in distance will be 20. Now, if we got these 2 as the answer, and now we know the meaning, that is, by how many times the dependent variable will change if there is any change in the value of independent variable. That is the meaning of slope. And that's why we say that change in D over change in V is equal to 2. And this is equal to slope. And slope has a symbol that is M. Therefore, from here, let us give the definition of slope mathematically from the foregoing concept. Now you see that slope is defined as change in y over change in x. We just said that slope is equal to change in d over change in v. How come we're not saying that change in y over change in x is equal to slope? Recall that this d is a dependent variable. When this table was shown on Cartesian plane, we recall that d was plotted on the vertical axis, and then this volume was plotted on horizontal axis. And then we also recall that it was this volume that determined the value of the distance. Therefore, the volume is independent variable, while the distance is the dependent variable. Don't forget that all independent variables have one symbol, that is x, while all dependent variables have the symbol y. Therefore, this formula is peculiar to this table, while this formula is general to all tables which contain dependent and independent variables. I hope what I'm saying here is clear. Now let's make progress. Recall also that this change in y can be gotten as y2 minus y1. Don't forget that this d here, this d, change in d, is the same thing as change in y, and change in d was equal to d2 minus d1 at the time we did it. It is still there. What it means is that if d is peculiar, then generally speaking, this d2 will correspond to y2. That is peculiar to this case, but this is general in every case. Peculiar to this case, that is d1, peculiar to this case, and then y1, general. That is why we rewrite this change in y as y2 minus y1. Why is it so? Because change in d is equal to d2 minus d1. Similarly, change in v is the same thing as change in x. This is peculiar, this is general. Therefore, what it means is that this v2 is the same thing as this x2, while this v1 is the same thing as this x1, except that this is peculiar to this case, This V1 is also peculiar to this case, while X1 is general. Therefore, change in Y is equal to Y2 minus Y1, while change in X is gotten by saying X2 minus X1. Because of that, slope is also defined more clearly as Y2 minus Y1 over X2 minus X1. Now let's pay attention to this table. Do you observe that a similar thing is true about it? A similar thing is true about it in the sense that anytime there is a change in this X from 1 to 2, for instance, there is a change of Y from 7 to 9. And when there is a change from 2 to 3, then there is a change in Y from 9 to 11. Then when the change is from 3 to 4, the change in Y is 11 to 13, and so on. Now, at this point in time, please watch that table again to find out if it is possible for you to use that same table to find the slope of this table, of this the physical situation or physical system which this table represents. Let me inform you that sometimes it is not possible to use just a table to get the slope. Sometimes the changes are not regular. Let me illustrate. With this table, for instance, the change kept being 2 everywhere. From 2 to 4, 2. From 4 to 6, 2. From 6 to 8, 2. From 8 to 10, 2. That means that there is a constant increase to the volume of the petrol. What about this distance? From 4 to 8, the change is 4. 8 to 12, change is 4. 12 to 16, change is 4. 16 to 20, change is also 4. It means that we also have a constant change or constant increase in the value of distance. The same thing is applicable here. From 1 to 2, the change is 1. From 2 to 3, the change is 1. From 3 to 4, the change is 1. From 4 to 5, change is 1. Then from 7 to 9, the change is 2. From 9 to 11, the change is 2. From 11 to 13, the change is 2. And from 13 to 14, the change is still 2. Therefore, with these two tables, we learn that we can get the slope from table directly. But let me repeat that sometimes it turns difficult, even impossible, to look at a table and therefore get the slope. When such things happen, what do? Surely we're going to meet a case like that in the future. But just now, it is just enough to hear from me that sometimes a table will not be enough to get the slope. Why? Because the changes taking place will not be regular. When a table is not regular and we want to get the slope, it is not all tables which are not regular that would give us opportunity to find the slope therefrom. But some of them make it possible for us to get a slope, but not from the table directly. When a table gives us a curve, then we understand therefrom that it is impossible to use any means to get the slope. In fact, slope of a curve on Cartesian plane is not a constant slope. Because of that, it is needless to speak about the slope of a curve. Instead, we speak about the slope of a curve at a particular point of that curve. In the meantime, we are dealing with a straight line sketch on Cartesian plane. Now, back to what I was saying earlier. If it is impossible or even difficult to obtain slope directly from the table, what do? We use a system I show you just in a short while. If a table is linear and it becomes difficult, even impossible, to use the table to get the slope straight away, this is what you must do. it is found to be working at all times, whether it is possible to make a table or the source of the slope or not possible. So this works at all times, while the table works only when we can design that is regular or constant change occurring in each of the variables. So what it means is that at all times, after we plot a graph and want to get the slope, that is rate of change between independent and dependent variables, this is what we do. We choose any point along that straight line or the line of best fit and draw a vertical line that runs downwards like this one. And then any place we want to stop, provided we don't go as far as where the line of best fit cuts the vertical axis, that is okay. I could as well have stopped somewhere here so it can run from here to this one. I could have stopped at this point to go so it can run from here to this one. But I have to stop here so that it runs from here down to this point. It will be wrong to go from here and stop somewhere here to go as far as where the line of best fit cuts the y-axis or vertical axis. So this is suggested. Anytime you draw such a triangle like this one from the line of best fit, it is suggested that you don't make it too big or too small. As you can see, this triangle is not too small. It is not also too big with respect to the size of the space occupied by this sketch. Anyway, in the course of time, with more examples, we see how we can draw triangles, right-angled triangles. Look at it here for the purpose of getting slope. But recall that this line of best fit is not for this table. It is for this table. That means that we're going to use this line of best fit to find the slope of this table. But first, let us use this table straight to find the slope. And later, we compare the slope we get from this table with the slope we get from this sketch. Let's see. From this table, we see that change in y is equal to how? y2 minus y1. It will be 9 minus 7. It could be 11 minus 9. It could be 13 minus 11. It could also be 15 minus 13. Any of them is what we refer to as y2 minus y1. In each case, the answer is equal to 2. Change in x is equal to x2 minus this x1. x2, x1 could reduce 2 and 1, 3 and 2, 4 and 3, 5 and 4. In any case, x2 minus x1 is equal to 1 because 2 minus 1 is 1, 3 minus 2, 1, 4 minus 3, 1, 5 minus 4, 1. In other words, change in x is always 1 with this table in view. Therefore, as before, slope is equal to change in y over change in x, and that will be equal to change in y is equal to 2. Place it here. See the 2 here. Change in x, that's change in x is equal to 1. So place 1 here. See it here. So when 1 divides 2, the answer is equal to 2. Therefore, slope is equal to 2. Let's keep this record of slope we got from this table directly, and later we compare with the slope we're going to get from this Cartesian plot. Now let's use this Cartesian sketch to obtain the slope for the same table. The formula remains the same thing. It remains change in y over change in x. From here to here is change in y. And what does that mean? From here to here corresponds to from here to here. Check it very well. This place is this 13, while here is this 7. Now, watch that this change in y is equal to 13 minus 7. This y2 is 13. It is this modified to y2. See the y2 here. Don't forget that when we were plotting this on the plane, this place was corresponding to 13. So this place, in terms of y, this y-axis is 13. That's why we said that y2 is 13. While this point corresponds to y1. y1, that is the lower part of y, is 7. That's why we said that y1 is equal to 7. Therefore, change in y is equal to 13 minus 7, and that is equal to 6. What about change in x? Let us see. Also, change in x is equal to 4 minus 1. How? It is now this x we are trying to concentrate on. If between this position and this position, there is a value. Which of these 1 and this 1 we regard as x1? That is going from 0. Which of them do you meet first? The one you meet first going from 0 is what we refer to as x1. Therefore, this 1 here is the x1. And later, as you go along the x-axis, you meet the x2. That is this one. So the x2 corresponds to the value of x, which this line meets when extended. This vertical line used for drawing the triangle for slope, when it is extended downwards, whichever value of the x it meets is called the x2. And this also, when extended down here, whichever value of the x it meets is called x1. Because of that, our x2 is 4 and our x1 is 1. That is why the change in x is equal to 4 minus 1, and the thing is equal to 3. What then is the slope? Don't forget that we are using alternative method to find the slope when it is not easy or even possible to find the slope from the table straight. Let's make progress. As you can see, slope remains change in y over change in x. Don't forget that change in y is 6 and change in x is 3. Therefore, slope is equal to 6 over 3. That is equal to 2. Therefore, slope again is equal to 2. Compare it with the one we got earlier. The one we got without using the sketch. The one we got from the table straight was slope is equal to 2. And now, after we got a slope from the sketch, we also have that slope is equal to 2. Therefore, whether we calculate slope from the table or from Cartesian sketch, if we have done what we ought to do, the slopes or the values are supposed to do the same thing as we have just seen in this case. The summary, therefore, is that we can get a slope straight from table. When it proves difficult, we get a slope from sketch, either Cartesian sketch or later as we see through graph when plotted. Now let us consider a second example on slope using this table and this Cartesian sketch. First, let us check whether it is possible for us to use this table to find the slope before we start using the line of best fit to find the slope. How do we know whether it is possible to find the slope with this table? As before, we check whether the changes in x are regular. That is, whether the same change occurs throughout the figures from 2 to 6, and the same change occurs from 8 down to 28. Let us first look at changes occurring in x from 2 to 3. The change is 1. From 3 to 4, the change is 1. From 4 to 5, the change is 1. From 5 to 6, the change is 1. In this case, the change is an increase. Therefore, with this x, we conclude that the change is regular or constant. What about this y? From 8 to 13, the change is 5. From 13 to 18, the change is 5. From 18 to 23, the change is 5. From this to this, the change is still 5. And again, the change is an increase. Therefore, we have a constant change of 1 here and a constant change of 5 here. Because we have a constant change throughout the column of x and a constant change throughout the column of y, we conclude that it is possible to use this table to find the slope. Let us see how to find slope with it. Just like before, we proceed in like manner. As you can see, change in y is equal to y2 minus y1, which is equal to 5. By now, you should have known what happened that made us get this 5. y2 is that which succeeds, and y1 is that which precedes. 8 and 13, when compared, will lead us to the conclusion that y2 is 13 and y1 is 8. Therefore, 13 minus 8 is equal to 5. If we are comparing 8 and 13, in which 13 is the y2 and 8 is the y1, what it now means is that change in y is equal to 18 minus 13. The same thing is going to be the answer. That is 5. The same thing happens wherever you go along this column down to this 28 here. Please confirm. What about this x? Change in x is equal to x2 minus x1. This succeeds. This precedes. Between 2 and 3, x2 is 3. x1 is 2. Therefore, change in x is equal to 3 minus 2, corresponding to x2 minus x1. The answer is equal to 1. What if it is 3 and 4? We are trying to compare. In that case, the x2 is this 4 and x1 is this 3. Because of that, change in x is equal to 4 minus 3, and that will give us the same 1. Try and confirm if the same thing is going to happen if you compare any other two successive values in the columns of x and y. Now, based on that, we continue. Therefore, slope is equal to change in y over change in x. That is to say, 5 over 1, because change in y is 5. That is, change in y is 5. Therefore, whatever we see change in y, we replace with 5 for this case alone. That's why this change in y became 5. This change in x became 1. When 1 divides this 5, the answer is equal to 5. Therefore, slope, whose symbol is m, is equal to 5. Now, this is the slope. And we're going to compare this value of slope we got with the value we're going to get if we use the plot, this sketch, to find the slope. Now, let us try to find the slope using this Cartesian plot. Let's see. All right, at this point, we look at the triangle again. As before, we draw a right-angled triangle. This is that right-angled triangle, in which the longest side is that line of best fit, a part of it. From here to here, corresponding to from here to here, make up the change in y, while from here to here corresponds to change in x. Now, at this point, let us use it to find the slope and compare it with the slope we found earlier from the table. We expect both to be the same in value. Slope again is equal to change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. y2 is 28. How do we know? By estimation, we know that this place corresponds to the value of y, where? 28. That is why it is here. This y2 is 28. What about y1? y1 is here. y2 is here. This y1 corresponds to what the value of y is. See it here. And that is 13. That is why y2 minus y1 is equal to 28 minus 13. What about change in x? x2 is this 6. That's why it is here. x1 is this 3. That's why 3 is here. Therefore, change in y over change in x is equal to 28 minus 13 over 6 minus 3. Certainly, what we do is that we convert this to a single number and this also to a single number. That takes us to 28 minus 13 is equal to 15. 6 minus 3 is equal to 3. Therefore, this entire expression here has been condensed to 15 over 3. Then, when 3 divides 15, the answer is equal to 5. Again, we say that slope, that is m, is equal to 5, which is the same thing we found earlier. This is a slope we found by means of table. This is a slope we found by means of the line of best fit, the Cartesian sketch. What about the intercept? Let us see how to go about it.